So 3.4, we're going to talk about solving inequalities using addition and subtraction. Okay, have you guys have done inequalities before, right? Can anybody, let's see, Logan, read this for me. What does this say?
That says that x is greater than 7.
X is greater than 7, right? So because this is the inequality here, this is the inequality. So x is greater than 7 always. The larger one is going to be on this side of the inequality, right? So if I switch this around and I go like this, okay, this means that x is less than 7, right? Because 7 is greater than x. Or another way to say it is x is less than 7. Another way to write this would be x is less than 7, okay? Now, sometimes you will see things like this, okay? Where there's a little equal sign here. If there's an equal sign here, this means that y is greater than or equal to -1. Okay, greater than or equal to -1. All right. Okay. So you can your book I think uses this notation, which is the same thing, right? Or this is the same thing. Okay. So how do I notate this on a number line? So on a number line, let's go ahead and see if I can write down x is greater than 7. Okay, so if I here, this is the number line, I'll call this 0, we'll call this 7. So x is going to be greater than 7, right? So it's going to be over here, okay? But it does not include the 7, right? It does not include the 7, and we notate that with an open circle here. We're going to put an open circle and say that x cannot be 7, but greater than 7. So x is greater than 7 would look like this. Or in other words, so that's how it would look like, okay? If I wanted to say this, where x is greater than or equal to 7, then I would put a closed dot because it includes the 7. I would put a closed dot and go like this. Again, x is less than 2, 0, so it'd be 2, less than 2, so I'm on this side, right? Now I'm on this side because it's less than 2. I would have an open circle and we'd go this way, right? Because there's not equal to, there's not, I denote that by the open circle here. Okay, so let's say that I had x is less than or equal to -1, right? Since I have the equal sign, it's going to be a closed dot, and it's less than -1, less than or equal to -1, so it'll be this side. Okay, so that's how I would notate, or I'll put this inequality on a, or graph it on a number line, okay? All right. Okay, so let's see if we can do this. Let's go to example number 1. Example number 1. Okay, the freezing point of water is 0 degrees Celsius. At temperatures at or below the freezing point, water is a solid ice. Write an inequality that gives a temperature at which the water is solid. Okay, so it says that at temperatures at or below the freezing point. So at or below the freezing point was 0. So at or below, right? So if x is less than or equal to 0, right? And if I were to go ahead and write this on a number line, it would go like this, closed dot, because I have the equal sign, and it would go like this, right? Okay. Go to page 141, page 141. On page 141, there is a addition and subtraction properties of inequality. In other words, if I have A is, so how would I read this? I would read this that A is less than B, right? In this case, I can add the same number on both sides and the inequality will stay the same. Okay, this is kind of like this, right? This is kind of like if A is equal to B, right? And if this is equalities here, not equations, right? In equations, I could go ahead and do the same thing. I can add the same thing on both sides and remains the same thing, right? Just as that, okay, I can do the same, I can say the same thing on inequalities, right? If A is greater than B, then I can add C on both sides and it does not change. For that matter, I can subtract C on both sides and nothing changes, okay? The inequality stays the same, okay? And that's what they're saying there, okay? So we can use this to now actually solve inequalities, right? So let's go to example number 2. Example number 2, I have m plus 5 is greater than or equal to 10, right? Graph and check your solution. So I need to solve this, meaning that I need to solve this. I need this by m by itself. So I need something m is going to be on this side. So I want to get rid of the 5, right? Because I want to be just the m, right? So if I subtract 5 on both sides, this goes away. M is now greater than or equal to 10 minus 5, which is 5, right? M is greater than or equal to 5. So if I go ahead and clock this, I have the equal sign here, so it's a closed dot. M is greater than or equal to 5, so it's going to be over here like this, right? Okay. That's how you do that. So example number 3, let's do one more. So this is similar, very similar to our equations, right? Example number 3, I have solved negative 10 x negative 12, graph your solution. Okay, so again, I want x on this, on a side by itself. I want x by itself, right? So since I have x minus 12, I need to get rid of the minus 12. The way to get rid of the minus 12 is to add 12 on both sides. So I'm going to add 12. So this one cancels out. All I have left is x. Negative 10 plus 12 is 2. This guy stays the same. So this is what I get. X is less than 2, right? Or 2 is greater than x, so x is less than 2. I want to go ahead and notate this on, if I'm going to graph this, right? 2 is not included because there's no equal sign here, so it's going to be an open dot, and it's going to be on this side, right? Like that. Okay.
Mr. On,
Yes.
why would the squiggly line go toward the 0 instead of to the right side?
Because x is less than 2, right? So it's
Oh, okay.
less than 2, right?
Okay, that makes sense.
Okay.
Thanks.
All right, good. Good question. All right, let's go on the last one, example number 4. Example number 4. We're gonna have triathlon. You are competing in a triathlon. Last year you finished a triathlon in 85 minutes. The table shows your times for this year's first 2 events. What possible times can you post in the running event and still beat last year's finishing time? So last year's finishing time was 85 minutes, right? So in order to beat this time, your total time has to be less than this, right? That's what it means by beating it, right? So you're coming in at a shorter time, right? So this is going to have to be greater than the total time. So you have 17 minutes plus 45 minutes plus, I don't know how much their running time is. I'm going to call that X. Okay, so this is where we are. Okay. So in other words, if I add all these times up and they are less than 85, I am beating the time. Okay. So on this here, I can combine these two because these do not contain the X. 17 plus 45 is 62. Okay, so this is the same. Now I want to get X by itself. I have a 62 here, so I need to go ahead and subtract 62 on both sides. 62 cancels out, I get X. Over here, I have 85 minus 62, which is 23. Okay, so X is less than 23, right? If I were to graph this, it would just going to be 0, 23. That's less than 23, so it would be not included, open dot this way, right? Okay. Any questions? Any questions on what we talked about? Okay, if there are no questions,